Hello everybody, today I'm going to continue with the Wolfram language tutorial. In this lesson we are going to talk about relational and logical operators, and I'm going to start with the basic comparison operators. In this block I am assigning x and y to different values, and I'm comparing them, asking if x is smaller than y. Because x was assigned the value 5 and y was assigned the value 15, then this expression will be evaluated to be true. And if I will change this symbol to ask if x is larger than y, then this will be evaluated as false. Okay, so this is the basics of Boolean logic, and aside from the larger than or smaller than, we can use larger than equal. This will evaluate to be true. And we have also the equal operator. So in this statement, we are checking if the value assigned to x is equal to the value assigned to y. Okay, so in this case, it is true. And notice that if I will introduce a new variable that was not assigned any value, then this expression will not be evaluated to be neither false or true. With this operator, we are checking if x is not equal to y, in this case because x and y have the same value assigned to them, so this expression will be evaluated to be false. This expression shows again the statement that x is equal to y, as we saw before, so we know that this is true. And as we saw in the last lesson that every arithmetic operator has a corresponding function, we can see that in the Wolfram language all the conditional operators have corresponding functions. So here is the greater function and greater equal and less and equal. So in this block of code, we have two assignment calls, but notice that the assignment is a little bit different as we saw before. This assignment is what is called set delayed, and this is a special case of assignment. You can see in the Wolfram documentation center that set delayed delays the value being assigned, and it maintains the right part of the assignment until it appears, then it is replaced and being evaluated each time. After using this language a little bit, you will gain the intuition of when to use the regular assignment or when to use the set delayed. But when assigning a variable this kind of expression that has symbols in it, it's a good idea to use set delayed, because maybe the symbols in the expression will change their value. So in this case, we are assigning q this expression and z this expression, and I will print q and z, and then we will check their equality. Okay, so what we see here is that q is being evaluated here, and then z is being evaluated, and their value is different. So this comparison evaluates to be false. In the Wolfram language, we have another comparison operator that checks if the expressions are structurally and syntactically identical. But notice that before running the comparison, the two terms are being evaluated, and this is why I'm using the hold function, which holds the expression in its form and does not evaluate it. When I will run this block of code this way, then 5 will not be structurally and syntactically identical to this expression. Okay, so I will run it and you will see. But if I will remove the hold function, then this term will be evaluated to be 5, and then the two terms will be identical, and this statement will be true. So we will continue with logical operations, and we already saw that we have special symbols for true and false. So this is actually pretty similar to what we have in Python. What is happening here is that we are evaluating this expression that will result in either true or false, and we are saving this boolean inside a new variable p. So x is not smaller than y. I think that x and y are equals, so this expression is false, and we are saving false to p, and then we are using this symbol which represents the not logic gate that will invert the boolean, and because it is false, this expression will be true. Another very famous logic gate is the AND gate. Notice that the not gate is a unary operator. That means that it operates on one variable, and that the AND gate is a binary operator. That means that it works pretty much like the plus symbol or the comparison symbols that we saw earlier. And so the AND gate will result true only if the two terms are true, and in this case, because p is false and the other term is true, the whole term will result in false. But if I will invert p to be true, this term will evaluate to be true. Another very famous logic gate is the OR gate. The OR gate will result to be true if either one of the terms will be true. So in this case, because one side is true, we do not have to know what the other term will be. It will result true either way. So in this case, even if I will change p, this will still be true because one term is true. The bool function will convert true or false to be 1 or 0. So in this case, this evaluated to be true, and so we received 1. And if I will change it to be, let's say, false, this will evaluate to be 0. So the wolfram language has all the logic gates as functions. So here we have AND, OR, exclusive OR, not OR, exclusive not OR, and not AND. Each one has its special form and definition. Now we will see a couple of interesting functions. So the majority function will receive a couple of parameters and will result in true if the majority of the parameters are evaluated to be true. So in this case, most of the parameters are true and this will result in true. But if I will change it to be like this, then the majority is not true and this will result false. All true is a function that will receive a list and another parameter that this will be the condition that we are checking. In this case, even q will check if the values are even, and all true will return true if all the items in this list are evaluated true by this condition. So because 3 is not even, then all true will return false. The function anyTrue will check if any of the items will evaluate to be true. So because we have at least one even number in this list, so the whole term will be evaluated to be true. And non-true will evaluate if none of the items evaluates true with this term. So in this case, because none of the items are even, we are supposed to get true. So let's continue with procedural conditionals. And this is where we will find the famous if statement. So with this form, what we are doing is we are evaluating this term, and if this term returns true, we will run this part, and if this will be false, then we will run this part. So because x was assigned a value larger than 0, we can expect this term to print true. So here what I did is to expand this if statement into a couple of lines. This is just for formatting purposes. With this condition, I am testing if the length of this string is equal to this value, then I will run this procedure. And this is a good place to see that the Wolfram language supports procedures. I mean, running a couple of expressions together by using the semicolon. So this allows for imperative programming. And if this statement will be false, then we will run this part. So let's test it. And yes, we can see that this string was printed in reverse because I used the string reverse function, saved what was returned into a new variable named d, and then printed d. If I would change this string, let's say to James, then this statement would be false, then we would print this string. We will learn about functions later in the series, but this is a basic function definition. This is the function name, and this is the parameter that it will receive, and this is the function's body. So what I want to do is to apply this function to each of the items in this list, and to check the sign of each item, and if the item's value is smaller than 0, then I will flip the sign, else I will leave it the same. This will result in changing this list to contain the absolute values it has, and this operator is the map operator that maps all the items in this list to this function. So if I will run it, we will get a new list that has all the negative values changed to positive ones. Here I am assigning 3 to the variable a and 2 to the variable b. And I will test if a is smaller than b. If it is smaller, then I will return 1, else I will return 0. So a is not smaller than b, so we will receive 0, but because I put the semicolon here, we will not get anything printed, so I can save this result into a new variable, and I will print this variable. Okay, so we got 0 as we expected. So now we will see that if I will comment this part out, the Jupyter Notebook still knows about A and B. So if I will run this code again, we will have the same result. But I can clear the values assigned to A and B this way. This will have A and B unassigned, and in this case, this comparison will have no meaning. So this will not be evaluated to be neither true or false. And in this case, we can add a third parameter to the if function that will be returned in the case that no evaluation can be done. So let's do it like this, as a no, and this will be printed out. So in the case that we need to test a couple of terms and to assign each term a corresponding value, so we can use the which function. So the which function has a bunch of terms and values, and it will test each term and will return the first value that yields true. So in this case, it will test if x is equal to 7, and if it will be true, it will return this term. Else, it will test this term. If it will be true, then it will return this value, and so and so and so. So in this case, because x is equal to 16, none of the terms are true, and we can set a default value by making the last term true, and this will allow the last value to be returned if none of the terms above are true. So in this case, we will print none. Okay, and if I will change x to be, let's say, 6, then we will receive b. The switch function is pretty similar to which. Its main usage is to be used in functions. So this is a function that will check the traffic light status. This is the function's name, and this is the parameter it will receive. And the body of the function is a switch statement. So status will be evaluated, and these are the cases. So if status is evaluated to red, this function will return stop. If status will evaluate to yellow, this function will return caution, and so and so. And the last case, using the blank symbol, will give us the option to define a default value for this switch statement. So here we can see tests for all the defined cases, and this last line will test the default case. So if I will run it, we will get the expected results. Another interesting function is the cases function. Here again, we are sending a list. Notice that some of the items in this list are integers and some of them are real numbers. And so this function will evaluate which of these items will evaluate true with this term. So here what is happening, that we are checking for any value that is not an integer. So this pattern matches any integer, and we can see it this way. If I will run the head function on an integer, it will return this. So any item that will match with this pattern, but using the except function will flip this logic to be everything but integers. So I can also add here a string and a symbol, and we will have this expression returning the list without any integers. And in this block, I want to show this condition operator. This condition operator works inside function definitions. So I've defined a function named f. It will receive a parameter named x, and it will be assigned with this body. So what happens here is that we are checking if x is larger than 0, and only if x is larger than 0, then I will print this string. And notice that what I'm doing with this symbol here is I am concatenating this literal string with the value returning from the toString function. The toString function will cast any value to its string form, and then I can concatenate them together to print them out. So if I will call this function with the value, let's say 4, that is larger than 0, then this condition will allow this part to run, and let's see it. Okay, so this was printed, but if I will send it a negative value, then nothing will be printed. Okay, so I hope you enjoyed this short series about the Wolfram language. Please consider subscribing and giving me a like. This helps me a lot, and I hope to see you in the next video. Goodbye.